Okay, let's go ahead and pick up where we left off. We're going to finish chapter 8 today. Now, the way we're going to proceed with this, test number 2 covers 2 chapters, chapter 5 and chapter 8. We will have one day that we'll spend reviewing for the test, working some of the practice questions, answering any questions you might have, looking at the study guide, that kind of thing. And typically, I think you like to have it where the review is the class meeting before the test date. At least that's what I've seen. So what that means is we're going to vote on a test date today. The class before that will be the test review. And again, to me, it doesn't really matter that much as long as you don't get too far out, okay? Because, for example, if you voted to have the test, let's say this is Thursday, so let's say you voted to have the test not this coming Tuesday, but the following Tuesday, whatever that day is. So we would review next Thursday, a week from today, for the test. Well, that leaves this coming Tuesday open, and we would jump back to chapter 6 and start on material that's going to be on your final exam. Okay, so that'll be, and when you take a look at that and you see your final exam material, and let me explain this also, you're going to see chapter 6, chapter 7, chapter 9, chapter 10. You're going to see a lot of chapters. And sometimes students look at that and they panic and they say, wow, we only had 2 chapters on the second test, but he's got 5 chapters listed for the final exam. Well, it's not actually as bad as it seems, because what happens is after chapter 8, when we go back to chapter 6 and 7 and 9, whatever, we're covering from that point on part chapters. Okay, in some chapters it may be 10 pages, in other chapters it may be 2 definitions. But since you open your book to that chapter, I'm counting it as we cover that chapter. So the way it works is your final exam is going to cover, and I'll know more about this as we get closer, but typically it's going to cover 6, 7, maybe chapter 9, and maybe part of another chapter. But again, parts of 6, parts of 7, parts of 9. And then you're going to have what's called a bonus test. And you're going to have that the same day as your final exam. It's a second test. Your bonus test is going to be a 15 question, okay, not 50, but 15 question test over an additional chapter that we will cover in class. And the way it works is any of those questions that you get right on the bonus test count 1 point added to your final exam grade. Now, not your final average, okay? Your final exam grade. So for example, out of the 15 questions, let's say you got 12 right, and you made an 80 on the final exam. Well, you get 80 plus 12, which you made a 92 on the final exam. And so that's a big help in addition to the bonus question, excuse me, the bonus points that you've had a chance to receive so far. And I may actually have a second bonus or extra point, something that you can do for 5 additional points. Okay, probably what it's going to be is the financial literacy event on November 15th in the Curtis Center Stables. That's going to be part of it. Now, of course, if you can't attend that, then I'll accept other things. But we want to try to get as many students as possible to that event. Okay, so second test, get that out of the way. Then we'll start covering material for the final exam. You'll also have your bonus test, and we'll be finished. All right, so questions about that?
So our final exam is our first.
It is. Yeah, your final exam is is test number 3. And I'm not sure, but normally it's the Tuesday of final exam week at 1 o'clock. I don't know. I think it's the Tuesday of final exam week. We'll worry about that when we get closer to it. We've got test 2 to worry about. All right, so do you want to vote on when to have the test 2 now, or do you want to talk to your friends, vote at the end of class? Again, it works, if there's a certain date you want to stay away from, then you need to lobby other people to vote your way.
What's the earliest date we can have?
The earliest day we would have it would be 1 week from today. We would review on Tuesday, have the test on Thursday. So another choice is the Tuesday after, well, the following Tuesday. Basically, as far as I would want to go out would be, I mean, basically you got three choices really. Either next Thursday, the following Tuesday, or if you had to, the following Thursday. Okay, 2 weeks from today. That's about as far out as I would want to go with new material because I don't want to start confusing you with the new stuff that we're covering.
How about Tuesday? You're gonna have a Thursday or two? I'm talking about the next Tuesday. After that Thursday.
Okay, talk about it at the end of class. We'll finish up the material early. So talk about it at the end of class. We'll vote on it, and then I'll know how to proceed starting next week.
Oh, wait. I think we already know our decision. 2 weeks from today, test, and then like the review.
Okay, we'll see. We'll vote on it. Do we need a debate on it before we do it? Like last night's presidential debate, do we need a debate? Okay, let's go ahead and get started on chapter 8. We'll finish this up. Now, just to remind you, we left off. We were talking. We had looked at the definition of what's called the capital asset pricing model, or the CAPM, and we said that's a model that links risk and return for all assets. So what that model does is it gives us a numerical percentage return that we would expect to earn based on taking a certain amount of risk on an investment. And up to this point, we haven't done that. Now, part of the capital asset pricing model is something called the beta coefficient. So we went through and talked about the beta coefficient. We said the beta coefficient simply measures how much a stock moves in response to the market, the stock market movement. So the market's beta is always 1.0. If a stock has a beta of more than 1, then it moves more than the market. If a stock has a beta of less than 1, it moves less than the market. So it's a little less risky. So that goes back to the risk-return trade-off. So this is where we left off. And the reason, again, that we looked at some newer betas from Tuesday, current ones. But the reason that I leave this up here from 6 years ago is because I wanted to point out that sometimes betas can really get screwed up when it comes to just some really odd occurrences. For example, this is 2 years after the financial crisis. Stocks were doing some really strange things. Banks were doing some really strange things. Automakers were doing some really odd things. And so these betas are unusually high for companies like Citibank and Ford Motor Company, and they tend to be unusually low for companies like Monster Beverage or Netflix. So a beta is a good measure, but keep in mind that beta is a historical measure. We're using historical returns. So what a beta tells us about a stock right now doesn't necessarily mean that's going to apply moving forward. All right, now based on betas, we can also calculate a portfolio's beta. Now again, this is just a weighted average, so there's nothing extremely complicated about this. If we have 10 stocks in our portfolio, each of those stocks will have a beta. But if we want to know overall what is going to happen if the market moves up or down, what's going to be the portfolio's beta, we simply calculate a weighted average. So just like we did with the portfolio return, where we had the percentage weight of a stock multiplied by, in that case, it was a return. In this case, it's the beta coefficient. So we're going to take the weight of stock 1 times the beta of stock 1 plus the weight of stock 2 times the beta of stock 2. We went through and talked about how to calculate the percentage weight of a stock. What does it make up of a portfolio? And so this is simply what you would do. And here's an example of this on the next page. Go ahead and get that. Here's an example of this on the next page where you have 5 different stocks, 2 different portfolios, and you've got, now this is called a proportion, but it's actually the percentage weight, okay? So it's what it says is that stock number 1 makes up 10% of portfolio V. Stock number 2 makes up 30%. Stock number 3, 20. And what we're doing is we're simply multiplying the proportion or the weight times the beta. And we would just do this for each of these occurrences and then add them together. And what you would end up with is something that looks like this. So this is for the beta for portfolio V. So the weight times the beta plus the weight times the beta, and we work through this, and we come out with a beta of 1.2 for portfolio V, and a portfolio W has a beta of 0.91. So if we're just looking at these numbers, we would say that portfolio V is riskier than portfolio W because it has a higher beta coefficient. It's going to move more when the market moves up, and it's going to move more when the market moves down. All right, so does that make sense? Portfolio beta is pretty simple, pretty straightforward. All right, now this is the actual capital asset pricing model. So we'll go over this. Let me kind of explain what all of this says. When you look at it initially, you may think, wow, that looks kind of nasty, but it's really pretty simple because you're given all of these inputs. You just plug them in and do the math. What this says is the required return on a particular asset, in this case asset J, is equal to the risk-free rate of return, RF. The risk-free rate of return, as the name implies, it is the rate of return that you expect as an investor for taking absolutely no risk. Now, the problem is we don't really have a true measure of a risk-free rate of return. So we have to use a substitute. And typically we use an investment such as a treasury bill, the United States government treasury bill, is typically the least risky of any type of investment. So we'll look at the treasury bill rate. Now we add to that the beta coefficient for the individual stock, and we talked about, we spent a lot of time on Tuesday talking about that, multiplied by the return of the market. Now, the return of the market, that would be, to be technically correct, that would be an annual return on every risky asset that you could possibly invest in. All stocks, all bonds, all real estate, all gold, all silver, all artwork, all antique car, everything. But again, we don't have a true measure for that. So to make it a little bit easier, we normally use something like the return of a stock index, such as the S&P 500 or the Dow Jones Industrial Average, a number that we can easily obtain. And then we subtract from that the risk-free rate. So again, you're just given these numbers, you're just plugging them in. Now, a couple of things here that I want to point out to you. If we take the return of the market minus the risk-free rate, this small portion of the formula, this is what's called the market risk premium. So it is what investors expect to earn between taking no risk, the risk-free rate, and investing in the risky stock market. So there's going to be some number. So maybe it's the return of the market's 8 and the risk-free rate is 3%. So you would expect to earn 8 minus 3 or a 5% premium for investing in the risky market. Now, if we take the market risk premium and we multiply it by the individual stock's beta, it's what's known as the stock's risk premium. Because this is how much additional you expect to earn by investing in this particular stock as compared to investing in a risk-free investment. For example, I gave this, let's say I used 8 minus 3 here, which was a 5% market risk premium, 5 percentage points. And then let's say that this stock has a beta of 2. So if we took 8 minus 5, which is 3, is that right? No, 8 minus 3, which is 5, multiplied by 2, we would expect a 10% stock risk premium for investing in this particular stock. So it simply gives us an idea of what we expect to earn over a risk-free investment. And then once we add the risk-free rate to it, it's going to give us what we expect to earn for taking a certain amount of risk by investing in a particular stock. So let me show you how we would plug these numbers in. Okay, here's an example. We've got a corporation here, a growing software developer. They wish to determine the required return on asset Z, whatever that might be. It has a beta of 1.5. The risk-free rate of return is 7%, and the return on the market portfolio of assets is 11%. Calculate the required return. So we've got what we need here. We need three variables. We need the beta, we need the risk-free rate, and we need the return of the market. And we have all of those. So we can start plugging this information in. So the required return on asset Z is going to be the risk-free rate of 7 plus the beta of 1.5 times the return of the market of 11 minus the risk-free rate of 7. Now again, it's really important to use the correct order of calculation here. So what we're going to do is we're simply going to take 11 minus 7, which is 4, multiplied by 1.5, which is 6. So that leaves us with 7 plus 6%, which means if we invest in asset Z, we would expect to earn a return of a positive 13% for taking that much risk. And again, this doesn't seem like rocket science, but this was a really big deal when it was first discovered. Now, the problem with this is, and the problem with the capital asset pricing model is, it's very theoretical. And if you read the finance papers written behind this that kind of came up with this, and you start looking through it, and you would never, ever read those unless you're getting a doctorate degree in finance. Then they make you read them, but you'd never read them for fun. But when you read through those, you see that when they put together the capital asset pricing model, they put together, there were lots of conditions on which this model were based. Some of them are realistic, some of them are not anywhere near realistic. So again, this is a good starting point for understanding risk and return. It's not something that I would necessarily use personally to determine what do I expect to return on an investment. And the problem is here. The risk-free rate, the return of the market, well, actually all three of these are problems. Because think about this. What if the risk-free rate, in our example, we said that it was 7. What if it's actually 5%? If it's actually 5, it's going to change our number here dramatically. Or what if the return of the market, what if we're using the wrong measure for the return of the market? What if it's not 11? What if it's actually 13%? Or what if the beta of the stock, which historically is 1.5, we just looked at the historical betas, we said it's what the betas are based on, the last 3 or 4 or 5 years worth of stock returns for this particular stock. But what if going forward, we have another financial crisis, and this beta of 1.5 is completely inaccurate, and the beta should actually be 2 or 2.5. Then your number here is really going to be incorrect. So again, this is a good theoretical starting point. You need to know how to calculate it, but other than that, again, if you take other finance classes, you'll kind of get a little more into this in terms of what can we do better? What out there is better to help us understand risk and return? All right, so everybody good with the capital asset pricing model? If you see this on the test, you can calculate it. If I give you the 3 variables.
Can you go one slide back?
Now the model does look impressive. So if you're talking to your friends and they happen to see your notes in class and they see this, they're going to be pretty impressed. They're going to think you're pretty damn smart. Okay, just don't tell them how easy it is to calculate. Good. All right. All right. Now, based on the capital asset pricing model, there's another concept that we're going to talk about for a few minutes called the security market line, or the SML. And the security market line is simply a graph of the capital asset pricing model. So if we take the formula for the capital asset pricing model and we want to graph a line based on that, we call that the security market line. And it says, the second bullet point here, it reflects the required return in the marketplace for each level of non-diversifiable risk, which we said beta is a measure of non-diversifiable risk. And so we're plotting essentially beta as compared to the required returns. Now again, you don't have to, I'm not going to ask you to graph a security market line. I just want you to understand what it represents, and also in a minute what happens when it moves or when it changes. So based on the security market line, we can, based on the information that we just looked at for the capital asset pricing model, we can draw a security market line. So you'll notice these numbers match what we just looked at back here in this example, okay, with the risk-free rate of 7. So notice here, we've got the required returns in percentage points here, so 1%, 3%, 5, 7, and the risk level is measured by beta here. So this is 0 risk, no risk. This is if a beta of 0.5, a beta of 1.0, which is the market beta, a beta of 1.5, a beta of 2. So if we want to graph our security market line that we used as an example, we start out with the risk-free rate. And the risk-free rate in that example was 7%. So that's going to be our origin. Now, from here, we have to have a second point to graph our line. And we can get there a couple of different ways. One way is we can work through the capital asset pricing model like we did here and find that at a beta of 1.5, the required return is 13%. So we can go out here to 1.5, go up to 13%. We can put our second point here, and we'll just connect our 2 points, and we have a security market line. But let's say, for example, we didn't want to work through this second point. What do we know about the information, the three variables we've been given, and beta coefficients? What do we know about this information that we can graph the second point on the line without actually having to work through all of this? Now, I understand a rainy Thursday afternoon is really not the best time to go over the capital asset pricing model, okay? But just stay with me here, okay? We'll be finished with this and we can move on to better stuff. Now remember, the return of the market in our example was how much? The return on the market portfolio. You don't have to think about that, you just have to read it off your paper. The return of the market portfolio in our example was 11%. Okay, very good. Thank you for participating. And we know that the market beta is always what? 1.0. So if we know the return of the market portfolio and we know that market beta is 1, we can simply find our second point by going out here to a beta of 1, going up to 11%, which is the return of the market portfolio, and again connecting the 2 points, and it's going to give us our security market line. Does that make sense to everybody? So we can do this a couple of different ways. We can work through it and find the point here, or we can simply use the return of the market and find our second point here, but it's going to give us our security market line. All right, now based on that and based on the security market line, there's a couple of things that cause changes in our basic security market line. One is going to be a change in inflation, the expected rate of inflation. A second item is going to be a change in the degree of risk aversion, and that is risk aversion, the risk aversion of investors in the market. So we'll look at each of these and what they do. The first item, a change in expected inflation. If we have our security market line. Now, our original security market line is this, I don't know, kind of greenish color line here. And what's happening here is, it says in the yellow box here, an increase in expected inflation will cause a parallel shift up of the security market line and all corresponding rates of return. So in this example, we expect inflation to increase by 3 percentage points, or there's 100 basis points in 1 percentage point, so that's 300 basis points. So we expect inflation to go up. And somebody remind me, in simple terms, what is inflation? Value of the money going down, or prices doing what? Going up. That's exactly right. That's all inflation is prices going up. So what this means is, as investors, we take a look at what do we think is going to happen in the future. And it includes lots of things. It includes what's going to happen with inflation, what do we think is going to happen with interest rates, what do we think is going to happen with the presidential election, what do we think is going to happen with, there's just lots of things that we factor into our expected returns on investment. So in this case, if we think inflation is going to increase by 3 percentage points, if we don't factor this increase into our expected return on our investments, we're losing 3 percentage points worth of purchasing power. So what this means is if we think inflation is going to go up by 3 percentage points, we're going to require from our investments 3 percentage points more from our investments than we previously did. So that's what we see here with the orange security market line. So notice at the risk-free rate, we increased that from 7. We included a 3 percentage point increase. So now the risk-free rate is 10%. And at all corresponding rates of return, notice they are 3 percentage points higher. So here at a beta of 1.5, we were at 13 previously, now we're at 16. Here we were at a beta of 1, we were at 11, now we're at 11 plus 3, 14. We've had a parallel shift up of all rates of return. Now, my question is, here in the green box, based on this happening, because we're now earning a higher rate of return, as investors, are we any better off? Why aren't we any better off? Because of inflation. That's exactly right. Because if we earn 3 percentage points more on our investments, but prices increase by 3 percentage points, we're no better off, we're no worse off, but we're no better off. We're basically where we started. So this is what inflation does. It causes a parallel shift up, or if we have deflation, which is pretty rare, but if we do that, it will cause a parallel shift down. Okay, so that's what you need to know about inflation. It causes a parallel shift up, and so that's in the yellow box here, okay? So that's the first item that will change the security market line. The second item that will change the security market line is a change in risk aversion. We said earlier, and we've talked about this several times, risk aversion simply means that you must be compensated for taking additional risk. It doesn't mean you don't like risk. It just means you have to be paid for taking additional risk. So let's say that this is our original security market line, again, the green line here. And for whatever reason, investors have become more risk averse. Now, let's take a step back here. The slope of the security market line reflects the degree of risk aversion in the economy. So here we are now. We kind of, it's not really a steep slope, not really a flat slope, it's just kind of in the middle here. Okay, almost maybe at a little bit less than 45-degree angle. But this is where we started. Now, something has happened that causes us as investors to become more risk averse, or we want to be paid more for taking risk. So what happens is the security market line, the slope of the security market line, because we are now more risk averse, it increases, it becomes steeper. And what that means to us is if we plot our points on this second security market line, the orange line here, now that we're more risk averse, it means we're going to require a higher rate of return at each level of risk. So as we move from a beta of 0 to 0.51, 1.52, you'll notice this is not a parallel increase. As we take more risk, as beta increases, we expect a higher percentage-wise rate of return. And it's increasing at an increasing rate, okay? It's not a nice parallel shift like it was earlier with the change in inflation. So, and again, what causes a change in investors' risk aversion? It could be anything. Investors become nervous because of job reports. How many people are unemployed? Housing starts, how many new houses have been started during the last 3 months? The presidential debate last night might have made some people nervous. The outcome of the election might make some people nervous. A possible increase in interest rates might make people nervous. And so what happens is this security market line is constantly increasing and decreasing in slope. But notice what happened if we become more risk averse. Again, this is where we were earlier, the very first example. At a beta of 1.5, we required a 13% rate of return. But now, because we're more risk averse, at a beta of 1.5, we don't require 13% any longer. We require a 17.5% return. At a beta of 1, we're no longer satisfied with 11%. Now we are requiring, where are we here? 14%. Why didn't the origin change? Why didn't the risk-free rate of return increase when risk aversion increased? Remember, this is what's called the risk-free rate of return. So how much risk are we taking here? Risk-free rate of return. If something is dairy-free, there's no dairy in it, okay? If something is risk-free, there's no risk in it. So it's a risk-free rate of return. So that's the reason our risk-free rate of return didn't change. There's no risk, so risk aversion doesn't affect our risk-free rate of return. But once we move to the right and we enter risky territory on our graph, so once we move just a centimeter to the right, you'll notice our required return increases because now we are in risky territory, and the increase in risk aversion does make a difference. And so that's why you see the steeper slope. All right, so does that make sense in terms of what's happening here? It typically will be a nice straight line like this. The problem, again, this is kind of getting into theory, but what I want you to, because really there is no actual security market line. You can't go out there and say, you know, I mean, maybe you can find one, but we don't really keep up with this. What we do as investors is we sort of keep up with what's happening with this type of security market line mentally when we're looking at investments. And so, for example, let's say that I think interest rates are going to increase dramatically in 2017. And I'm thinking, wow, some of the stocks I invest in, I don't know if that's really going to be good for them. And so I'm thinking, okay, I don't mind staying in the stock market. I don't mind staying invested in these stocks, but now I'm more risk averse. So I require a higher rate of return to stay invested in these stocks. And if I don't think I'm going to earn that higher rate of return, then I'm going to sell those stocks. I'm going to get out of them. So it's not necessarily that we have this to look at as investors. It's just this is what we're thinking as a market overall. Now there are some outliers, okay? Some people are going to bet against what's happening with risk aversion. And that's what makes our market work, because if we all thought the same way, it wouldn't function. There has to be people that think, they're thinking positive about whatever's happening. There are people that are thinking negative, and these are people who are willing to buy or sell, and that's what makes our market work, supply and demand. Okay? But that was a good question. Other questions about the security market line? Now, to go back to what you just answered, I guess, for example, and we really don't get into this much, but for example, let's say that past a beta of 2, which you're getting into really, really risky investments when you get to a beta of 2. Let's say at that point, we become ultra risk averse. We don't mind taking a certain amount of risk, but we want to be paid for it up to a beta of 2. But past a beta of 2, then we may become ultra risk averse. Then I guess, at least theoretically, you could see the slope actually increase more. So you might have, this nice straight line to here, and then from this point forward, you might have a steeper slope. And that could happen. But again, that's up to the investing public overall to determine that. Okay, so what I want you to know is these two items, that if you have a change in inflation, it's going to cause a parallel shift of the security market line. If you have a change in risk aversion, it's going to cause a change in the slope of the security market line, up or down. And this, we've already actually talked about this. It talks about the capital asset pricing model. Is it right or is it wrong? A lot of the assumptions, for example, this says the capital asset pricing model assumes that our stock markets are efficient. And we'll talk more about this in chapter 6 when we talk about something called the efficient market hypothesis. But this is saying that our stock markets always have to be efficient. And we can see that our markets, for the most part, are pretty efficient, which means that whatever a stock is selling for at a certain time period, that's what it's worth. But there are times when, if you have the right information, you can consistently outperform the market. And typically that right information is called insider information. So if you have access to information that other investors don't know about, you can consistently outperform the market. The problem is that's illegal. So we'll look at some of that later. But again, this is simply saying that, is the capital asset pricing model right or wrong? It's not really right or wrong. It's just a good starting point, as I mentioned earlier, for understanding risk and return. That's basically all it is. And that is chapter 8. So are there any questions about chapter 8? All right, you have made it through the statistical chapter, okay? Chapter 8, you have survived it. So we're finished with that. Now let's vote on your test. Wouldn't have your test. Somebody give me some dates, if you would, of
Next Thursday is the 27th.
So next Thursday is the 27th. Or I'm guessing the 3rd. Okay, so
I'm not really smart about it here. Alright, so the 27th is like the weekend of homecoming, and then like that Tuesday, nobody's gonna study it during homecoming, so I think the Thursday the 3rd is prom.
all right, so have you had a chance to talk, air your opinions, air your grievances, call your fellow classmates a liar, whatever it might be? Let's turn around, look in the face, and go, "You're a liar," okay? That is not happening. All right, so how many people, we'll just take them in this order. If we have the test on the 27th, that means we will review on Tuesday, next Tuesday, have the test 1 week from today. So how many people vote to have the test on the 27th? Raise your hand. Whoa! If either presidential candidate could get this kind of response, okay, I mean, all right, so I don't think there's really any reason to split it between the two. So we will have test 2, the 27th. That's democracy in action, man. Democracy in action. All right, so we're going to review on Tuesday. We will have the test on Thursday. It's going to be just like we had the first one, 50 questions, multiple choice. We'll talk more about that on Tuesday. Everybody have a great weekend. Let me say this. Start studying as early as possible, okay? There's a lot of calculations on this test, working with your calculator, so be working practice problems. I'll see you on Tuesday. Have a safe weekend.